Good evening to all of you. Here we are with the continuation of yesterday's session. The third session is of AISM for CA, IPCC and Inter students. Kindly attend and share with your friends. Here is CSR Bharath Kumar sir to follow this session. All the best and happy learning. Over to CS Bharath Kumar sir.
Thank you. Happy evening, dears. So we are here on a fresh day to start with EIS. We have completed yesterday on strategic management. Today we will start with IT, enterprise information systems. So once people join us, we will go quickly, start with what is our portions today. Happy evening, Abhinaya, Nisha, Shanmati, Sidhu. Happy evening. Good, maybe we'll wait for a minute or two and then we will start. Sai Shri Ram, Surya, Rakshana, Vishnu Priya. Good. Asha, happy evening. Good. Okay. Now we'll start slowly with the concepts. Yes, Nisar is joining. Very good. Happy evening. Good. Now we'll start with the fresh chapter, information system and its components. We need to know this very basically. What is this? What is system? What is information? What is information system? So let's go one after another before we go inside and see what is there for the screen. What is there in the screen? We'll slowly go forward. Whenever you wanted to say something called system, we will immediately remember two systems. One is going to be the human system and another is going to be your computer system. So for any system, you need to have certain things for it to function. Let's take for an example. When I ask you what is there for your system to function, you will say, sir, we will have to eat. Correct. You will have to breathe. Yes. So you will have to ensure that you have a good living. Yes. All the functions of the body, all the parts of the body should function. Mainly major things which heart should function, and certain things for which and all you need a necessary functioning, you will try to say it should function. Only then it will do it. Yes, I would not say no, but in that particular processing, for example, when you wanted to breathe in, you will not keep on breathing in. For your breathe, there are three things required. One is your input, another is your process where which you will have a air circulation, and then you will have an output. Exactly the same thing. Whenever you have a computer system also, there are three things which are very important. What are they? Input, processing and output. Now we call it as IPO. For a system to function, we need an IPO. The same thing when I connected with law, I will say for a public offer, you need to have IPO. Correct? Whenever you go for listing, that is initial public offer. I'm not going inside that. So what are we covering? We are covering the major thing called input, processing and output. So you will have IPOs to remember. Now, whenever we studied computer, we would have studied a word called processing. When we tell processing, it is converting input into output. So the process is the flow where you will convert input into output, but the system is combination of input, processing and output. Now the beauty is whenever you connect with the word called system, it is independent and interdependent together. Independent means what? You don't need to wait for your hand to move only because only when your leg moves, your hand should move. Not necessary. It will do independent activities, but automatically, for example, when you're writing the CA examination, hand only will be working, brain is not working. Do you think so? No. You will have to hand, eye, then brain coordination should be there. All the three coordination should be there. So that is interdependent. So the beauty of the system is you need to consider that You should also have independent, you should also have interdependent functioning. Only then it is going to make your job easy. Now we know what is system. Now we will go and see what is information. Information, before knowing what is information, we should know what is data. Data is raw facts and figures. That means when you try to connect, yesterday also we connected this, when we connected EIS to valuation of inventories, the flow for you to remember is raw material, work in progress, and finished goods. Correct? So when you wanted to say raw material, it is more like data. It is all raw facts and figures. With that, you can use it and process it further and then proceed for decision making. When you have only raw data and raw facts and figures, it is called data. So that is more like your raw material. When you process the data, it becomes information. So processed data is equal to information. You can accordingly try to remember it. So I can also write it here. You will know what are we talking about. So let's take for an example. I will try to connect it here and say what are that we are trying to talk about. We are talking about something called system. When we told system, we told IPO. Yes, when we told IPO, we also told data. When we told data, we told raw facts and figures. Yes, so that's what we are writing here. Now, what is information? When you wanted to keep information, you call it as processed data. Correct? That's what we are trying to write now and making it really, really strong. So system will always be considering input, processing, and output. And we should not stop here. We should also say the IPO should be independent and also interdependent. Independent and interdependent. The data is always raw facts and figures, and information is always processed data. Now, when we tell technology, we will use a word called information technology. That means what? With the data, you will not be able to do anything. But when you process the data, it becomes information. Information is equal to processed data. So it's easy for us to understand clearly. Now, this is only one side. Now, but when you wanted to cover the examination, you just don't need information alone. You need to have something called knowledge. So what is knowledge? Knowledge is equal to information plus power or decision making. Whenever you wanted to take a decision making with the information, you will ensure that knowledge is required. For example, when we cover the subject called EIS, I don't just share data with you. I am not just giving you information with a processed data. I am telling conceptually how it will actually work, what are the examples, how you should know, in corporate, how it will get covered, all that if we tell. So we are based on that particular information, you are going to take a decision. You are having that power to take that. So information plus power is equal to decision making. If you remember in the school times and all, you will usually write the proverb in the blackboard, or now it has become whiteboard. Correct? Blackboard, whiteboard, whatever it is, you will write knowledge is power. What we have written that in the school, I am now trying to connect and say knowledge is power. Right? When you have information with the power or decision making, it is called knowledge. That's how you will try to remember. Now, when you wanted to have this information, you connect that with system and you call it as information system. There are various components of information system. If at all you try to see what is information, what is system, when you combine together, when you get information system, you will have many components. You will have many components. So write it and keep what are all the components of information system. So I will also write here components of information system. What are the components of information system? You will try to have something called hardware, okay, plus software, plus network, plus database, plus user. So these are the components of information system. Whenever you wanted to cover the components of information system, you should know these are the things that you will try to have: hardware, software, network, database, user. Now, we wanted to connect the components of information system now. How we are going to connect? Yes, you need to have a control over it. Now, information system also has a point called control. Now, I'm making the basics really strong. So, I am writing the word control here. When I wanted to have control over something in organizational structure, I need to have three important things, or maybe four important things: policies, practices, procedures, and organizational structure. So what I will say, I'll again repeat: practices, policies, procedures, and organizational structure. You need to have four important things where you will ensure those controls can either be prevented or detected and corrected. Now let's take for an example. Whenever you have a risk, when we cover SA 240 in auditing, we will cover something called risk. The fraud, correct? When you wanted to cover your the fraud, you will try to cover up, there will be risk, and you will have to accordingly manage it and find what is the solution for risk. You can try to have a control over the risk, as simple as that. Risk and control. The control is the solution, risk is your problem. When you wanted to know what is this risk, that's what we are going to take it tomorrow. It will cover all the risk related terms of your business process automation and core banking system. Today, we will cover up the information system components, which includes your control also. What are the controls I told you? Practices, policies, procedures, organizational structure, which can be either a preventive control or detective control and corrective. What does that mean? Yes, Sai Sriram has told audit risk has inherent risk, control risk, and detection risk. Fantastic. Now, that's what I am trying to say. When you cover auditing, you will cover three types of risk. Here, against that risk, you should have controls, and see, that's the connection between your sixth paper and seventh paper. Now we tell sometimes, sir, EIS is very raw subject, theory subject. Correct? That's what we usually say. Now we say we are connecting the auditing with information technology, EIS. So automatically you have, already we will connect with EIS and SM. Yesterday itself, if you still remember, when we were talking about functional level strategies called logistics, I told logistics will not be separate. You should also know what is supply chain management. Supply chain management is the extension of logistics. So automatically you should go and connect with your business process modules of your EIS. So that's what we told. So what is this control? We will quickly write this and go to the next level. We will say 3PO. 3PO plus PDC. This is what we told in simple words: practices, policies, procedures, organizational structures, which can be prevented or detected and corrected. Why I am saying detected and corrected? Because either you will have a preventive control. That means we will say prevention is better than cure. Before something happens itself, you will try to prevent it by way of a control. Once you are not able to prevent, automatically you will try to detect it. You should try to detect what is the problem. And once you detect, will you stop there? Yes, I detected. Now everything is done. Will you stop? No. Once you detect, you will try to do correction. So prevented or detected and corrected. That's what you will try to connect. That's what the word control comes into picture. So what is this 3PO? Practices, policies, procedures, and organizational structure, which can be prevented or detected and corrected. Yes, Asha told it very clearly. 3PO plus PDC. Yes. Now let's go and see the concepts inside the information system components. I already told you 5 components are there: hardware, software, network, database, and user. What is going to be this? Now, when you wanted to cover input device, when you wanted to cover hardware, you will have to remember a concept called, input devices, processing devices, output devices, and data storage devices. Indirectly, what are we talking about? We told hardware, you will have to remember iPod. So yes, we are making this strong. I'll put that in the yellow so you will understand it. So iPod. iPod is the answer for remembering the hardware. What is this iPod? Input devices, processing devices, output devices, data storage devices. Don't you think so? Whenever you wanted to listen to a song, you need music, correct? You cannot take music from the nature, correct? You will try to take the nature, you will try to take the music from a particular instrument. So you can remember hardware is visible and you will have iPod. So you can remember iPod as the way that you can easily remember. Yes, Nisha came back with an answer saying iPod. Very good. So when you wanted to say iPod is the mnemonics, is the easy way to remember, but that's not the order. IPDO is the order. What is this iPod? Shall we tell? I is input devices, P is processing devices, O is output devices, D is data storage devices. So you can remember iPod very easily. Now, when you are connecting this iPod, input processing, output will not come. Output will go to the end, because after processing data storage, whatever is the connection between your processing and data storage, then only it will go to output devices. So you will have to write it. IPDO is the correct order. So you can accordingly remember iPod. So what is iPod? Input devices, processing devices, output devices, and data storage devices. Now let's go one after another and try to find out what is going to be here. Now I have displayed here what are the input devices. Whenever you wanted to think what is there in input devices, we will say normally keyboard will be there, mouse, light pen, joystick, whatever it is. There are many examples for input devices. So you can accordingly remember your input devices which interacts with the system. Now that's not the important thing to remember, because you already know, we have studied this from the school. What is the next one? Processing devices. In processing devices, there are three important things. If you quickly remember, I would have used a mnemonic called CAR. I would have used something called CAR. What is this CAR? Control unit, arithmetic and logic unit, and registers. So you can remember that very easily and say arithmetic, logic, control unit, arithmetic and logic unit, and registers. There are three important components in processing devices you will have. What control unit will do? It will control the flow of instructions. That's what I would have given here. It will control the flow of instructions to and from the system. Correct? So it will not do anything beyond that. Control unit will do that. What ALU will do? ALU is what? Arithmetic and logic unit. What it will do? It will do arithmetic operations like addition, subtraction, multiplication, logical comparison. Correct? What is this logical comparison? Greater than, lesser than, greater than equal to, lesser than equal to, like that it will try to compare and make it strong. Now, when we said processing devices, what did I ask you to remember? CAR, C-A-R. You know, control unit will only do the controlling the flow of instructions. What is A? Arithmetic and logic unit, which will perform arithmetic operations like addition, subtraction, multiplication, and all. We made it very strong. And you have in that R, CAR, R is registers. What is this registers? It's a very small memory unit. It will register some important data, some important addresses, and it will try to do the general purpose that the computer system does. All that will be there. There will be many things. Yes. So Abhinaya has come back with an answer called mass. Yes, very good. MASS is how you will try to remember your registers. What is this mass? Mass means types of registers. That's what we use a mnemonic. Miscellaneous register, address register, storage register, storage accumulator. So there are four things. What are the four things? Miscellaneous register, that means general purpose register. Address register, it will store only addresses. Then storage register, it will store only the data that is relating to whatever they wanted to use. And storage accumulator, accumulator is cumulative values. Like when we try to say 1 plus 2 plus 3, we will say 1. 1 plus 2 is 3. 3 plus 3 is 9. 9 plus 4 is 13. Like that, we will try to do cumulative numbers. Correct? Like that, it will accumulate the data and the addresses so that it will be used for further processing. So what is this registers called? This registers is going to be 4 in number. What are they? Mass, miscellaneous register, address register, storage register, storage accumulator. Guys, I will tell you what is this beauty. When you are sitting in the examination hall from 1:45 to 5 o'clock, the beauty lies only from 1:45 to 2. If you are really strong and you are able to tell the answer in a quick way, Even before you see that question, when you see that question, even before you think about some other answer, if you are able to remember it, that's the way you can try to finish your EIS with an exemption. What is that we are trying to do? Concept is very important, as I have already told you. But from 145 to 2, the confidence level that you will have to bring, that determines your passing. So for that, you cannot keep only concept. You should also try to improve memory. That's what we have told here. That's what we told yesterday in your morning session of SM and evening session of SM. I again and again repeat, because we need to know two things. I am not making you mug up things here alone. I am also telling you conceptually what's happening, and also I am telling you a memory technique so that you will never miss out the flow. Wherever you go and see iPod, you should only try to remember hardware. Wherever you try to remember the PDC, wherever you see a post dated check PDC, again you will have to remember control only, correct? So like that also we can remember how to have a control over the check. Give a post dated check, so you will have a control. So how to remember? Control is PDC: preventive control, deductive control, and corrective control. So that's the way you can try to remember. Now we call this as mind mapping. Whatever we try to understand with whatever we already know, if you are able to connect this with EIS, you will be able to remember it better. Please take this from me. This is how if you do for other subjects, you can manage. Knowledge will go for a long term, but at least till the examination, you should ensure that what is the keywords you will have to remember for what. That's what we are doing. Mass, we have already told: miscellaneous register, address register, storage register, and storage accumulator. Very good. Now, data storage devices. What is that? I am coming back again. You remember iPod, I, input devices, P, processing devices, D, data storage devices, O, output devices. We are done with input devices. Processing devices, we told what is car. Then we told data storage devices. Then we will have to go for output devices. What is this data storage devices? In a fun way, we will try to say, if you wanted to pass IPC, when your IPC wants to become very simple, you will have to put everything in your data storage device. Don't you think it will be easy to remember? What is this IPC VS? IPC is not your integrated professional course making very simple. That is not IPC VS. That's for your understanding, I told. What is this IPC VS? Internal memory, primary memory, cache memory, virtual memory, and secondary memory. So what is that? You will have to remember: internal memory, primary memory, cache memory, virtual memory, and secondary memory. So we should accordingly remember that there are 5 data storage devices. So how did you remember? We told it very easily: IPCVS. Okay. Now, what is this IPCVS? Internal memory. Internal memory will have a connection between the registers, which we told in the processing devices, and it will have a connection with the cache memory. So what is this? We will go one after another. Internal memory is simple. From the registers, whatever it is going to be registered as a data or addresses, and the frequently used memory location, it will be saved in a place called cache memory. Cache memory is a bridging memory. It is between two memories. What is this cache memory? See the next point. If you see, we were talking about the cache memory. Cache memory is between registers and primary memory. Registers, we already told, it can be miscellaneous register, it can be address register, it can be storage register, it can be storage accumulator. Easily you can try to differentiate what they wanted to cover. Now, that's not the point. You should also connect with primary memory. In primary memory only, 2 important memories will be there: RAM and ROM. What is RAM? Random access memory. What is ROM? Read only memory. So you can easily remember what is your random access memory and read only memory. Now we should try to connect this cache memory. Cache memory is between what and what memory? Registers and primary. First write all these things and keep. So then I will proceed. So first we will write what is there for hardware: iPod. What is there for your processing devices? Car, control unit, arithmetic and logic unit, registers. What is there in registers? 4 registers are there: mass, miscellaneous register, address register, storage accumulator. If you are able to remember all this, then we will come to data storage devices, which we call in simple words called IPCVS. Internal, primary, cache, virtual and secondary memory. Now internal memory, we told it is between registers and cache memory. So what is this cache memory? We started saying cache memory is between registers and primary memory. That means we are bringing the registers from the previous memory and we are also connecting with primary memory. Now for that we should know what is registers and primary memory. We already told what is registers. Primary memory has two things: RAM, ROM. Random access memory, read-only memory. We will not stop there. We will say RAM capacity only is very important. That means you can read and write. You can again and again read and write on that particular memory. And they also call it as RAM is volatile memory, ROM is non-volatile memory. I'll again repeat: RAM, RAM, random access memory, is volatile. They will ask this in the MCQ. Please mark it important. What is volatile memory? Correctly you will confuse in the examination. So now itself I am telling RAM is V, ROM is NV. Okay, don't consider that as veg non-veg. Correct? So V and V. So but still you can remember ROM is always veg. So you can easily remember like that. Though it may not, it may be a bit of fun, but still you can remember RAM is always V. Volatile memory. RAM here. That's what we call it as. RAM is volatile memory. ROM is non-volatile memory. What is volatile? Let's go and one after another and see. When we say volatile, we say till the power is there, information will be retained. That means what? Information is lost when the power is turned off. That means what? Till the power is there, information will be there. That's what is the purpose of volatile memory called RAM. So write volatile, very important keyword. Information is lost when the power is turned off. Volatile, information is lost when the power is turned off. I'll give you 2 minutes so that you can write whatever I asked you to remember. If you listen to this video again and again, you will understand what we are trying to say, so that you can stop, again listen to it, stop and again you can listen to it. It will be easy for us to go. Maybe why I am going in a bit of speed is for a simple reason, to cover up the I'm trying to cover up the whole chapter today, which is not actually very easy, but I'm trying to do. Let's take it like a challenge and see how much we are able to complete in this particular 2 hours of time. Yes, volatile means what? Information is lost when the power is turned off. What is non-volatile? Information is retained even when the power is turned off. That means when there is a point, what it is called non-volatile, even when the power is turned off, information is retained. Non-volatile means what? It has got no connection with the power. It will always be there. You don't need to wait for the power to come. Automatically you will be able to get the information. Let's take for an example, pen drive. Correct? When we say pen drive, we will say it's a secondary memory. But don't you think when the data is stored in the pen drive, even after you remove the pen drive and the switch off the system, don't you think still the memory is already there and the file is there? Yes, non-volatile. Even when the power is turned off, when the information is retained, it is called non-volatile. Like that only ROM also does. I'm able to connect with secondary memory, which I'm going to tell you the next one. Yes. Now, what is that we are talking about? The registers and primary memory. In between that only, you will have what? Cache memory. So we told about registers. Now we told about RAM and ROM. Now we should go to cache memory. What did I told you? I told it is a bridging memory. It will compensate the speed difference. Registers is very small, but quite faster. But RAM, ROM and all primary memory, which is huge, because when we connect the system, when we say what is the configuration of the system, you will only tell about the RAM capacity. You will not tell about the registers capacity and all, because it's a very small memory. For small data storage only they will try to use. So don't you think when you are connecting the registers and primary memory, there will be a speed difference? Yes, registers is small and quite okay, but RAM will be in quick speed. Don't you think the processing should happen properly to compensate the speed difference and to bridge the speed difference? Between the registers and the primary memory, we will have what memory? Cache memory. So write cache memory is equal to bridging the speed differences between registers and primary memory. Please write this and keep. They have asked n number of times cache memory and virtual memory. So cache memory is compensating the speed difference or bridging the speed difference between registers and primary memory. Please write this and keep. You know what is registers, you know what is primary memory. Compensating the difference only is cache memory. Yes, if you are now done with what is there for registers, primary memory and cache memory, we will go to virtual memory. Virtual means what? Actually it is not there, but it will try to do the job. That's called virtual. Here, virtual memory, what is that? You have guessed. Yes, you have guessed it correctly. It is not the actual memory, it is only imaginary memory. So what I will write here, near virtual memory, I will try to write imaginary memory. Imaginary memory. Virtual memory is otherwise called what? Imaginary memory. So when they say imaginary memory, then how it will be there? It will be supported by hardware and operating system. What is that? In the next line I have written HW and OS. What does that mean? The hardware and operating system will help. It will form a structure to ensure that virtual memory is available. It is not actually there, but it is going to be helpful in that. How it will be helpful? See the next point. Virtual memory is used when the RAM is low. When the RAM, when it is low, that means when it runs very low, what will happen? You will not be able to process it. Let's take for a simple example. I wanted to carry some 15-20 books. Okay, I am the RAM. I wanted to carry 20 books, 15-20 books. Now I am not able to carry because RAM gets hanged. Correct? I am not able to manage. If it is 5 books means I'm okay. Now I am asking some person to come and help me, and he is coming and helping me. He is taking some 5 books and he is waiting for me there, or he keeps it in a separate place. And I wanted to go and keep that 5 books and keep in the place. And then when I come back, he is trying to give me that particular remaining 10 books, and then I am collecting and keeping in that particular place. Now am I processing better? Yes. Now what am I doing? I am the RAM. My processing, when I am too much involved, it gets crashed. Suddenly when the system gets crashed, you will ensure that all the system files will get closed because I am not able to manage properly. So the RAM will carry the full processing, but if it is running low, what will happen? Like how I gave it to the another person, virtual memory will take that files from the RAM and put it in a place called paging file. So virtual memory will collect the files from the RAM and put that in a place called paging file. Now what will do? RAM will process and it will do all this processing, and then it will make it go to the output devices. Now RAM has become free. Now what RAM will be there? RAM will be available now for processing. Now virtual memory will take that data from the paging file where it kept. From the paging file, it will try to take and give it to RAM. Who will give? Virtual memory will give. So virtual memory will move the data to and from the paging file when the RAM runs low. That's what we are trying to say here. See what I have written. When the RAM, when it is low, virtual memory moves the data from RAM to a paging file and vice versa. That means when the RAM is too much held up, the virtual memory will take the data and put it in a place called paging file. And when the processing is already done from RAM, from paging file, the data will be collected and it will be put into the RAM. Who will do this? Virtual memory will do. V. So only I'm showing V. Virtual memory will do it. So I'll again repeat. Virtual memory. When the RAM is low, the virtual memory moves the data from the RAM to a paging file and vice versa. So cache memory and virtual memory, they will ask again and again in the examination. We should be careful about it. What is cache memory? I told you it compensates or bridges the speed difference between registers and primary memory. Then when we told this, we told virtual memory also is like one memory that is between, that will be helped by hardware and operating system. When the RAM is low, virtual memory moves the data from RAM to a place called space called paging file, and then accordingly it will give back when the RAM wants to process. This is what is done by virtual memory. Are we clear? So the virtual memory, you will have to remember that this is automatically done, virtual memory. So virtual memory, yes. So when you wanted to cover the virtual memory, this also gets done. And the last is secondary memory. Secondary memory is what? Secondary memory, I already told you. Anything that is not directly accessible by CPU. I told non-volatile. You should have understood this. Non-volatile. What is this non-volatile? I will try to say it's not directly accessible by CPU. That means what? It is not within the CPU. It will ensure that it will be outside the CPU, like your USB, your pen drives you can use, hard disk, external hard disk, correct? So CDs, Blu-ray disc, whatever you call it as, you will cover that in the secondary memory because it is non-volatile memory and it is not directly accessible by CPU. Outside the CPU only it will be there. So indirectly, you can try to remember internal memory, primary memory, cache memory will be within CPU. Virtual memory is imaginary memory. Secondary memory will be outside the CPU and it is not directly accessible by CPU. This is what they will try to say here. And we have already completed what? IPCVS. Now listen carefully. I'll quickly visualize. You will get it. Hardware is equal to iPod. Input devices, processing devices, output devices, data storage devices. Input devices, we have some examples like keyboard, mouse, joystick, light pen, etc. Processing devices is equal to CAR. CAR, control unit, which will control, arithmetic and logic unit, which will perform arithmetic operations. Registers are small memory, which we call it as mass. So you would have easily remembered that. And we completed processing devices. Then we went to data storage devices. We told data storage IPCVS, correct? So I, internal memory, P, primary memory, C, cache memory, V, virtual memory, S, secondary memory. Internal memory, we told registers and primary memory will be connecting. We already told registers, so we told primary memory is equal to 2, RAM and ROM. RAM is volatile, ROM is non-volatile. Volatile means what? Information is lost when the power is turned off. Non-volatile, information is not lost even when the power is turned off, or you can say information is retained when the power is turned off. That means you will always have that information. So cache memory will bridge the speed difference between registers and the faster primary memory. We can accordingly remember. Imaginary memory is what memory? Virtual memory. We called it as V. Virtual memory will be supported by what? Hardware and operating system. Indirectly, guys, I have covered some 30-40 MCQs here itself. Okay, please understand, when you study the concept, you should not see only as a concept. You can also cover it like MCQ. So indirectly, we are covering the whole thing. So we say virtual memory supported by dash and dash. Automatically, the answer is what? Hardware and operating system. Yes, what virtual memory will do, when the RAM is very low, when it runs low, automatically the virtual memory moves the data from RAM to a space called paging file, and it will try to bring back again when the RAM requires the processing. Secondary memory, we told it is outside the CPU like USB and your Blu-ray disc and external hard disk and all. So it is non-volatile NV, which is not directly accessible by the CPU. Now in that IPD is done. What is O? Output devices. You already know what are the output devices that we have. Generally we'll say printer, plotter and all, so you can easily remember. But how I will ask you to remember? I will ask you to remember it as CRT pills. What is the CRT pills? So we will say output devices is CRT pills, cathode ray tube, which we use it for the word called monitor. CRT is what? Cathode ray tube. What is this pills? Plotter. I, inkjet printer. L, laser printer. Another L, LCD or LED, and S is speaker. So easily you can remember all these words. So by remembering output devices, you can remember it as CRT pills. So you can remember what is the CRT pills? Cathode ray tube and plotter, inkjet printer, laser printer, and LCD or LED speaker. This is what we will try to cover, and this is what we have it in hardware. So hardware only we have completed now, and which we would have completed easily 30-40 MCQs. So that's what we covered hardware. iPod is done. Now we'll go to software. What is this software? We will say, sir, we cannot see software, but through the help of hardware we can do. Okay, very good. Now when you cannot see software, what is that we can connect as an example? I usually sell the gas cylinder. What is this gas cylinder? You need the cylinder for keeping the gas inside. Okay, but gas cannot be seen. You can only feel it and you can only smell it, and you cannot be seeing it. So software also is like that. So you can remember, you need a cylinder called hardware, and you need gas inside that for covering, and the gas is called software. The cylinder is called hardware. Why am I telling that? There is a purpose why I wanted to bring this gas cylinder, because when I say gas for the software, it is general software G, application software A, system software S. Easy to remember. So when we say general software, application software, and system software, don't you think easily you can remember gas? Yes. Whenever after this, when you see a gas cylinder in home, what you should remember? You should remember only software. What you will have to remember in software? Gas is what? General software, application software, and system software. This is how you can easily remember and finish. What is there in general software? Nothing. It is general purpose. Application software, you need to know what is application software, you need to know what is system software. But before that, in system software, you will have a concept called, you will have a important coverage called operating system. There are various components in system software, but they were all removed from our syllabus. Previously it was there in ICA syllabus. They will use a word called module concept, PODUL. Programming languages, operating system, device drivers, utility programs, language translators, all these things, compilers, interpreters, and all we were having. Now we did not have everything. We just brought the concept called operating system alone. We say OS, correct? Operating system alone is there in system software, and you have application software. General software is only for concept. Now if you see, for any system to run, when you switch on the laptop, for example, you wanted to see this video, so switch on the laptop. When you switch on, automatically it will start boot up, correct? The process will be booting up, and it is all process. The possibility of process is done only when you have your operating system inside. Only then you will be able to boot the process up. So system software, what they will try to say, they will say system software is for the purpose of running the computer. For the purpose of running the computer or machine, you need to have what? System software. And the system software should have what? Operating system. Let's take for an example. Sir, I have a mobile. In that mobile, I don't have games. For that mobile to switch on, don't you think I need to have an OS? Yes. So what is operating system? I told, for the running of the computer. Please understand, when I say computer, don't think only the dabba with the CPU and UPS. In the computer, when we tell, that also is only a mnemonic or an abbreviation. What is this computer? You will have to remember first what is computer. So we should know computer is nothing but your computer, correct? So when you wanted to say computer, it is commonly operated machine purposefully used for technological and educational research. So what is computer? COMPUTER is commonly operated machine, particularly or purposefully used for technical and education research. That's how they will try to use a word called computer. Now you should not think computer means it is only the dabba, correct? So I already told you what is computer. Commonly operated machine, purposefully used for technical and education research. Now computer means don't think it is that only, correct? Any system, even the mobile will be more going to be called as a system. So for that computer to work on, you should ensure that for the running of computer, you need what? System software. Beyond the running, for example, I have a mobile phone, I don't have a game. So where I will go and take it? I will take it from the app called application store. Now, for you to have the system running, you need to have operating system. Beyond the running of computer, if you wanted any software to be downloaded, you will take it from the application app store. So you will try to say application is beyond the running of computer itself. So for the running of computer, you need system software. Beyond the running of computer, you need application software. So you can easily connect this and we can make our job easy. Now, what is that we should know? We should know what is there in application software. You should know what is there in system software. So please remember this. I am going to the next page, which will try to cover your application software and system software. Now, see the point here. When I wanted to cover this application software, there are 7 types of application software. Please mark this very important for exams. There are 7 types of application software. You can remember this. When you see the system, you will be able to understand that there are 7 types. We will remember it as MICS. What is that? You need to have something called media development software, where you can ensure your publishing of the desktop can be done, video editing can be done, all this can be done. Second, information worker software. For you to run the computer system, for you to work with the software, you need to have spreadsheets and CAT, computer assisted audit tools or techniques, computer assisted audit techniques. So content access software. For you to listen to a song, you need to have a media player. For you need to open a PDF, you need an Adobe Digital. So these are all your content access software. So I'll again repeat. There are 7 types of application software. You can remember it as MICS. What is this C? Content access software. What is this? Yes, suite application software. What does that mean? Bundle of applications, we call it as suite application. What is this bundle of applications? You will ensure Word will be there, Excel will be there, PowerPoint will be there, Access will be there, Outlook will be there. All the applications are bundled together. So you will ensure that MS Office applications are suite application software. Please mark this question important, as I've already told you. What is this triple E? Enterprise software? Don't you think for an enterprise you need a software like ERP? Yes, enterprise resource planning. The small software you will call it as Tally. The big software you will call it as SAP, Oracle and all. Okay. So enterprise software, the examples are ERP applications like SAP. Don't call it as SAP, call it as SAP. So ERP applications like SAP. Now next is enterprise infrastructure. To run the enterprise software, you need to have a security. So email servers and security software is the most important example you can write. Why I am covering only examples? Because they are covering this in MCQ. The ICA asks, what is the example for enterprise infrastructure software? Or they will ask you, email servers are the examples of which software? So we should know very clearly what we are going to talk about. Are we clear? So enterprise infrastructure software will cover 2 things: email servers and security software. Last is educational software. You can get your examination test CDs, the CDs that you give, pen drive classes that you wanted to, all that is based on application they will develop, and then is done Zoom, StreamYard, whatever it is, everything is an application, and accordingly you will have to have something called educational software. So how will you remember? MICS. Media development software, information worker software, content access software, suite application, enterprise software, enterprise infrastructure software, educational software. Please write this. Maybe if you want, I can zoom that and show you so that you can remember and write it. Please try to use your laptops when you wanted to see this video so that it will be very clear on seeing up. You can also write it down when you wanted the keywords to be written. Okay, the more you see in mobile, you will have to zoom it and see. So if you see it in laptop or desktop, it is easy. So please take this down. I'll give you 2 minutes time. You can accordingly remember it and write. MICS triple E. They will ask you the examples. Again, if you see indirectly, some 20-30 MCQs are already done. So you can manage it very easily. The reason why I am not discussing or visualizing is I wanted to cover a decent level of portion today. So I am not asking you any questions. People who are there in the chat will not be able to answer anything because I'm not asking you any questions. The more we complete the portion, it will be better so that many people can watch this and get benefited. You are done with this types of application software. Now we should know what are the activities of operating system. Operating system will do many activities. So we will try to remember this. Are you able to see this? Activities of operating system. What am I doing? I am telling you what and all the operating system will do. So you can remember that very easily. This again is a important question from ICAS angle because these are all concept related questions. The mother body will concentrate on the concepts only. So they will easily ask you this question, what and all the operating system does. First, number one, hardware independence. That means operating system will be there, but it will make the hardware independent and it will do whatever interface you wanted to create for your other things, you can accordingly try to do it. So they will use a word called API, application program interface. They will only, this interface will be used by the application developers to know how to segregate. They will say partitioning. If you remember the word called virtualization, we will use a word called partitioning. What is that they will do? They will segregate what and all is for your software and how the hardware is connected. So API is application program interface, which is used by the application developers to create the application software. Yes. What is the next one? User interface. Generally, guys, when you boot the system, when you open it, automatically, it will try to show your desktop and menus and icons will be coming. Correct? In your menus and icons in Windows, if it comes, how it is automatically coming? Because when you have an operating system only, you will try to have an user interface called graphical user interface. If there is no operating system, you will not be able to get all that. That only will boot the system and you will get it. So GUI is called what? Graphical user interface. Separately, they may also ask in the expansion, what is API? Application Program Interface. What is your GUI? Graphical User Interface, which uses menus and icons. That's what they will say in user interface. What is the third one? Memory management and file management. It will try to manage the memory. It will try to manage the files. And usually we will say operating system uses what memory? Virtual memory. Now only we told it is going to be virtual. So virtual memory, we told now only it will be covered through what? It will be covered through your operating system and your hardware. So we say from the RAM, it will go and put it in a place called paging file. You remember all that? That is helped by operating system, we told. So in operating system, we are trying to connect from virtual memory. In hardware, we touch the software. In software, we are touching the hardware. So OS uses what memory? Virtual memory. That is one more point. So how did you remember memory management and file management? What is the fourth one? Performing hardware functions. It will try to do all the hardware functions like input, processing, output, data storage. It will help in all the hardware functions. That is your fourth point. Fifth point is task management. What does that mean? Multitasking. It will not be doing only one task. It will do many tasks, and it will ensure that all the resources are utilized. Resource utilization will be done, and they call it as multitasking. So task management is done. What is the last point? Actually, 2 points I have combined here: year on year variance on network access capability and logical access security. What does that mean? Every time whenever the net is connecting with a good speed, you should have the windows updated, or you should have an operating system updated. Only then you can match up the speed. If you're having an old operating system, how you will have a connectivity? So for that, you need to have your better network access capability, and main thing, logical access security. You should have an ID and password to protect that particular system, and that will also be helped with the help of operating system. So what is the first point? We will remember all these points as HUMPTY. HUMPTY. Easy to remember. What is this HUMPTY? Number one, hardware independence. H, U, user interface. M, memory management and file management. P, performing hardware functions. T, task management. Y, year on year variance on network access capability and logical access security. So you can connect this very easily with the help of user ID and password, and they will try to provide the better capability for you to connect with the internet. So are we done? We are done with HUMPTY. Yes, HUMPTY. Now I will ask you some questions. Are we ready? Yes, so that the people in the chat also can be able to do. So we have already completed hardware and software. Let's try to do that. Now I'll ask you questions. People who are watching the video now can answer. People who is going to watch this video later also, you can visualize like that. Okay, first question I will ask you, and wait for people to answer. When I say registers, how many types of registers are there? How did you remember? Registers. When I say registers, how many types of registers are there? How did you remember? Can you answer me? Yes, very good. So when you wanted to cover this, we use a word called mass, correct? Registers and primary memory, and you can accordingly remember that. Very good. So mass, very good. So many people have come back and said 4 types are there, and it is called mass. Very good. Next question. Next question I'll ask you. When I say cache memory, it will bridge the speed difference between what and what? Cache memory will bridge the speed difference between what and what? Many people have answered. Very good. Cache memory will bridge the speed difference between what and what? Very good. Registers and primary memory. Very good. Why, Malavika, I told internal memory is not connect? Because when you say internal memory, it already has registers. So don't say like that. You will have to say registers and primary memory. Yes. Shanmati has told RAM. Yes. RAM only is not the one. It is primary memory on the whole. RAM, ROM. So accordingly, you can remember registers and primary memory. Very good answer. Good one. Fantastic. Now, how many types of application softwares are there? How did you remember? Next question. How many types of application software are there? How did you remember? What am I asking you to do? I'm asking you to write the mnemonics and try to remember the examples. Let me see how far you are able to get this. MICS triple E. Very good. All the people are right. Good, good. Registers. So yes, registers we have completed. Now I'm asking you types of application software. MICS triple E. Very good. Now don't you think when they ask like this in the examination hall, quickly you will remember MICS triple E and then you will start writing? Yes. What is this media development software? All these things we showed, correct? You remember this? So this is what I am showing now. So media development software, information worker software, content access software, suite application, and enterprise software, enterprise infrastructure software, and educational software. Easy to remember? Yes, very good. Now, good. Many people are answering. I'm so happy about it. Okay. Now we are done with hardware and software. Now tell me the remaining components of information system apart from hardware and software. Can you tell me in the chat box? Can you tell me in the chat, apart from hardware and software, what are the remaining things we have in information system components? Quickly tell me the answer. Let's see how far you're able to get that concept strong. Yes, very good. Suparna, yes, network, database, and users. Very good. So you should try to connect with database, network, and user. Very good, very good. Malavika, right. Nisha, you are right. Very nice. Good. Now, when we wanted to cover with database, you should connect with what? You should connect with the previous topics. Yes, Priyanka, you are right. Very good. Now I'll go and connect with the layers. See what is that I have given here. I am connecting now with the database. Database means what? It is collection of data. When I wanted to collect data, it is called database. When I wanted to process the data, it is called information. Are you getting the concept? So when I collect data, it is called database. Let's take for an example. There is a book that is written, and that one particular page I did not like. Example. So I am tearing that into pieces. When I tore that into pieces, now what is happening? Everything becomes data because it is all raw facts and figures. You cannot do anything with that tore paper. So what I am doing, I am collecting all this data and keeping it in hand. When I collect all the data, it becomes what? Collection of data, which is called database. Which is called database. When I collected that, with that, will I be able to proceed? Yes, I'll be able to proceed if I process that data. So with the collected data, when I arrange it like a jigsaw puzzle, so automatically you will be able to get an processed data. With that, I can do something about it, and we call it as information. So information is equal to what? Processed data. So knowledge is equal to what? Processed data plus power. But what is the data that is collected called? That is called database. But you will not stop there. When the institute material wants to cover database, they will not stop there. They will say, what is the flow of database? The flow of databases, there is bits. Bits is called binary digits. See what I have done. I have written something called database flow. I have written BCFRFD. If you are able to see that, zoom it and see, you will understand what I am talking about. Bits. The bits means what? Binary digits. Binary digits is zeros and one. When you collect the bits, it becomes byte. Collection of 8 bits is called byte. Byte is otherwise called characters. Now listen carefully. I have bits. Collection of bits is called characters. Collection of characters, when I collect all the characters, I get fields. Collection of all the fields, I will get record. Collection of all the record, I will get one file. Collection of all the files, I will say it is database. That's the flow of the database. Now, when I say flow, will you change the order? No, you will not change the order. You should try to remember it in order. What is this database flow? Bits, characters, fields, records, files, database. What is that? Bits, binary digits. Collection of bits is called characters. Collection of characters is called fields. Collection of fields is called records. Collection of records is called files. Collection of files is called database. So they can ask this in MCQ also. How? Database is equal to collection of what? Files. Files is equal to what? Collection of records. Records is equal to what? Collection of fields. Fields is equal to what? Collection of characters. Characters is equal to what? Collection of bits. Bits is what? Binary digits. That means the small categories, if you combine together, and then when you have a capacity, you will ensure that you have a database. Please write this and keep. They may ask you this in the MCQ and say, arrange it in the order. So you will have to arrange that in the order. Bits, characters, fields, records, files, database. Please write it down. Please write this down. Let's make it really, really strong. This is called flow of database. Don't change the order. The flow, life cycle, stages, phases, all this has to be not for changing the order. You should write it just like that. There is going to be no change in the order. If you are done with the database flow, what is the next one? Models of database. Models of database. So when you wanted to have models, we will usually say 4 models of database are there. How did you remember? I have already given the mnemonics here. HORN. HORN. What is this HORN? Hierarchical database model, object-oriented database model, relational database model, network database model. So how many database models are there? 4. What are they? Hierarchical database model, object oriented. Yes, Nisha has come back and say HORN. Very good. Hierarchical database model, object oriented database model, relational database model, network database model. Easily you can remember HORN as a model of database. Now, what is this HORN? Hierarchical. What is hierarchical? We will usually use a word called inverted tree pattern approach. Usually how the tree will look like. First there will be branches, then there will be stem, and there will be root. There will be inside the soil root. If you invert the tree, what will happen? You will have root, then you will have stem, then only you will have branches. Correct? This is what they call it as hierarchical database model. That means otherwise called what? Parent child record. What does that mean? Dad and mom. So for your dad and mom, your brothers, sisters are there. Correct? Some 4 5 people. Now after that, previously, or maybe for example, let's go 3 generations before. Your grandmother, grandfather, they have 4 daughters and 4 sons. Each daughter and son got married, and there will be daughters and sons to them. So 3rd generation, 4th generation, 5th generation. But who is the root? Grandma and the grandpa, grandmother and the grandfather. So don't you think they are the root record? From that only you will try to have different branches. We usually say it as family tree. So you will have many branches that is coming. So inverted tree pattern approach. So they will be having root there, and then accordingly you will try to get all the branches as a next level generation. So what is this they are trying to talk about? Let's take for an example. I wanted to take a book from a building. Okay, so that building has some 15 floors. Okay, let's take for an example. I am asking, I am in the ground floor. I am asking a fellow to go and say, I left my book. Can you please take it and give me? He says, yes, I can give it to you. Where I should go? I told him very clearly, there are totally 15 floors. Go to the 10th floor. He says, okay, I went to the 10th floor, but there are 7 houses are there. Which house I should go? I said, in the 7 houses, go to the 4th house. Okay, he went to the 4th house. He is saying there are 3 rooms are there. Which room I should go? I said, go to the 2nd room. In the 2nd room, there will be 2 tables there. Which table I should go? First table. In first table, there are 4 books are there. Which book I should take? I said, take the 2nd book, which will be called EIS. So take that and book and give it to me. Now, don't you think I have told the root very clearly that it is 10th floor? If I have not told it is 10th floor, he will be loitering to the remaining floors. So he should go to the 10th floor. In that 7 houses are there. In that one house, and in that 3 rooms are there. So I am making it very clearly from one parent record. I am going to the small branches, and I'm going to tell and say this is how you will collect the data from, and he was able to make it very strong. So what is that I told? One building. So one to one. I asked him to go one to one relationship. In that many rooms are there. In that one room you will have to go. So there are two relationships you should have: one to one relationship and one to many relationship. So hierarchical database model. Please write number one, inverted tree pattern approach. Number two, parent-child record. Number three, two types of relationship: one-to-one relationship and one-to-many relationship. Write it and keep. Write this and keep, so that they may ask you which is called parent-child record, otherwise called. You don't need to even think. Immediately you can think and say inverted tree pattern approach means it is called hierarchical database model only. So like that you can try to remember. Please write this and keep. Yes. Now what is the next one? Object oriented. Object means what? Images, audios, videos and all you will have, and we call a database management system called object oriented database management system, which will provide all these details. So that's your point. Object oriented database management system. Yes. Images, audios, videos. Next, relational database model. What is the connection between the other data and records? You will try to have four important ingredients for your relational database model. One is called domains, attributes, relationships and records. Relations and records. You will have four important ingredients. I will, in a fun way, usually tell this how to remember the relational database model. I will usually tell this in a fun way. There is nothing to hurt people, but I'm just telling it for fun to remember the concept. For the CA students, one of the most important enemies are the relatives. Okay, because they will not know what is CA also, but they will come back and say, you will remember that they will come back and say, which college are you studying? Correct? You will say, I am not studying in college, I am studying CA. CA is under institute, it is not college. And they will ask one more hypothetical question: when will you complete this CA? Correct? You will not know. What you will say? You will say, if I know, why will I ask you? You are asking me a question, why will I answer and all? So I made it very simple, saying that when you find the relatives itself, you will have a fear. When you have the fear, what will you call in Hindi as dar? DARR. So I ask the students to remember relational database model means remember your relations. Automatically you can remember. You will have a fear which is called DAR, and automatically keywords also will be there. What is DAR? Domains, attributes, relationships and records. Easy to remember. DARR. Domains, attributes. So whenever you wanted to have records, you should try to have relations. And the relations, when you wanted to connect with that particular data, you need to know the characteristics of it, and it is all based on either rows or columns, and it will be called domains. So that's the easy way to remember. You can remember there are four ingredients or for your relational database model, and it is called the network database model. How it is connected with hierarchical and network. Hierarchical is only one branch. Network is many branches. See what I have given. I have told emanating from multiple branches. That means out of many branches that you have, you can easily connect it and say it is not one branch, it is multiple branches. So there will be four types of relationship. What are the four types of relationship we have? One is to one, one is to many, many is to one, many is to many. So please write this and keep. Hierarchical database model, only two relationships. One is to one and one is to many. And database when you cover your network database model, you will have four relationships. One is called one is to one is to many is to one, many is to many. Correct? So there are four important things to remember. Please write it and keep. So that's the difference you will connect between what? Hierarchical database model and network database model. We have keywords and all to be written inside this, but I am telling it on a high level because if they ask you MCQs, you will be like this answering all these questions. So that's very important from our side. we usually start saying, let's make it simple, correct? So we should accordingly always remember that it is not just saying for the sake of doing, you should actually make it simple. Okay, so when you wanted to cover this, we covered the database also. Network, there are many things in network. The important categories that you will have to remember. For example, if it's old syllabus people who are listening to the old syllabus in the video, you will have third chapter fully called telecommunication network. You will have models, you will have classification, you will have topology, you will have transmission. I'll tell you one after another. What are the 10 questions? You will have models, you will have classification, you will have topology, you will have transmission, OSI model, threats and vulnerabilities, network security techniques and protocols, internet, intranet, extranet, e-commerce, m-commerce, and electronic fund transfer. Totally, you will have 10 concepts which will cover some 60-65 pages of your material. But when it is new syllabus people, you will not concentrate more on the networks technologies, but still you will have topology. Topology, the common portion I am covering. Topology, you can say it is a physical arrangement of computers in the computer network. So write the heading topology, T-O-P-O-L-O-G-Y. They will call it as network topology. So right, you can remember this, both the syllabus can remember. And for mainly for the new syllabus, we will have only topology and some small points. I'll tell you the two questions which are very important. Number one, topology. You have 4 topologies with you. Number one, star topology, bus topology, ring topology, mesh topology. So 4 topologies are there. Please write it and keep. Definitely for old syllabus or new syllabus, it is a favorite question from our institute. They will definitely ask because highly conceptual. So they can ask you that. I'll again repeat. There are 4 topologies: star, bus, ring, and mesh. Star topology, bus topology, ring topology, and mesh. Yes, Abhinaya told it correct. Very good. There are 4 topologies to remember. Yes. Next is very importantly, please write internetworking processor. I will tell you all the 6. Please study that for your exams. It's going to be important. Why am I telling this important expected question? Will you study CA like this? No. You will have to study everything. But we know what the conceptual way of learning things and how they will ask you accordingly from the frequently asked question. I am covering up the suggested answers. I have seen the suggested answers before. I have seen the examiners comment from the ICA because our ICA will provide us what and all is the question asked, how the people have answered, what and all the mistakes that they are making, everything. We will have to study this as a faculty, and only then we can tell the people that this will confuse you. This will confuse you. They may ask this question. 90% of the people have written like this, so we can accordingly tell. So based on that, I am telling you that these are all questions that are important. We don't do like what we do in the school, correct? We are doing a professional course. We cannot come back and say like what we did in school, mark from here to here. They will definitely ask this question. It's not like that. It's about what is material, what is only for concept, what is for exam, what is only for knowing the flow of the chapter. That only we are segregating now. So please understand that in a very right way. Now, when you wanted to cover this internetworking processor, there are 6 internetworking processor. I will write it here itself so that you can accordingly remember. So I'll put it here. So I will write internetworking processors. So there are 6 internetworking processors. You can accordingly remember. Internetworking processor are 6. One is called switch, router, hub, bridge, repeater, gateway. So any of this one can come in the examination. Switch is intended destination. This will be very clearly given in the institute material. Neatly two lines only will be there. You can go and connect that. Switch is only intended destination. Router is like a traffic controller. We will usually say router is traffic controller with the protocols. So I will write traffic controller. So you can remember easily that it will route properly accordingly. So based on that only it will try to connect that. So you can accordingly remember that in that way. It is called traffic controller. So that's a way that you can remember with what traffic controller means, how you will do it based on your rules. And here we call it as protocols. So this is how you will try to remember your router. Traffic controller with rules or protocols. Hub. Hub is more like junction box. What I am trying to do, I am quickly making it so that you can cover that with the example. You will have 3-4 plug points. You can connect wherever you want. Like that, you will have something called junction box. And junction box like that, if you are able to do it for networking, it is called hub. Port to switching communication process. You can connect LANs, workstations, printers, servers, etc. You can connect that in the hub. Next is bridge. You know, from in our place, from one side of the road, when you connect it with another side of the road, you will try to have something called bridge. Downwards, in the downways, you will have water. So one way to another way, you will try to have bridge like that. One land to another land, when you wanted to connect, you will have something called bridge. It will connect numerous lands, and that component is called bridge. A repeater. Repeater means what? Again and again you repeat till you get the proper result. Correct? So what is that? That's what they will say repeater here. It will boost or amplify the signal before it passes to next section of cable in the network. So please read this repeater and gateway. Repeater is, it will amplify, like how the stabilizer works. Correct? Every time there will be boost and buck, it will accordingly change the fluctuations and make it strong. So like that, repeater will boost or amplifies the signal before it passes to next section of cable. You should always remember networking can be with wire, without wire. In the technology term, we will call it as bound media, unbound media, guided media or unguided media. Guided media means with wire. The unguided media means without wire. So you should know repeater will be like that. Gateway, payment gateway. Correct? What they will say, whenever you processing the payment, it will say, don't press escape or refresh. We are connecting that to your merchant gateway. So don't disturb the process. It will tell you. Computer will tell you. Correct? So what does that mean? You will have one network architecture. The merchant will have another network architecture. This payment gateway only will connect. And through that, you will try to say 128 SSL and all, it will go. Correct? Secure socket layer. So that's how it will prevent your frauds, the credit card frauds or your other frauds to have an encryption. 128 encryption SSL. Now, if you see, you will try to connect that in the gateway. So all that is to your protection. So you will have. So please mark this and keep. They will definitely ask you inter-networking processor. Are we clear with that? User, there is nothing. So these are your information system components. These are your information system components. What more question is there? I will also write this. One more question is there, which is important in your, important in your information technology on networks. It is called transmission modes. So transmission modes, there are 3 things you will have to remember: simplex, half duplex, and full duplex or duplex. Sorry. Full duplex. Now, transmission modes. What is this simplex, half duplex, and full duplex? Very simply, they will ask you this question. It's important. You can also remember this. When I have a mouse, correct? I have a mouse. This is wireless mouse, correct? Now, when I wanted to give this from the printer, when the mouse wanted to do, I am going and connecting that with the printer and saying, now print this particular page. So the communication is moving from what? From mouse through the system, it is going to the printer. Now tell me, is anything coming from printer to mouse? No. So it is called what? One-way communication. So one-way communication is called simplex communication. That means from one way to another. In simple words, it is mouse to printer. You can also remember the TV and remote. When something you wanted to switch on, everything is going from the remote to TV only. Nothing is coming from TV to remote. Correct? It is called simplex communication. What is this half duplex? Half duplex is two-way communication, but not at the same time. What does that mean? We will say walkie-talkie, if you remember, correct? So when another person speaks, there will be two people talking, but there will be a proper way of connecting. Once that fellow completes the speaking, he'll say over, then only another fellow will say over. Then he will start, other fellow will start speaking, and he will say over. Like that, there will be keep on moving from one place to another place. Don't you think so? That's called half duplex. Two-way communication only, but not at the same time. Yes, walkie-talkie, very good. Abhinaya is coming back. Yes, very good. Nisha, very good. Walkie-talkie, two-way communication, but not at the same time. Phone, mobile phones, video conferencing and all is full duplex, because two-way communication, but at the same time, you can easily remember your full duplex. So they can ask you what are the transmission modes, what are the examples. They can ask you TV remote, or they can ask you walkie-talkie, or they can ask you what is called full duplex. You can cover that with your MCQs. This is what is your information system components that we need to cover. What and all we covered now? We covered 5 things, because there is nothing in user. User is nothing but the people. So we covered 4 things. What are the 4 things we covered? Number 1, hardware. Number 2, software. Number 3, network. Number 4, database. Number 5, user or people. Now I'll quickly ask some 5-6 questions, then we can go to the controls, which is again very important for the old syllabus as well as new syllabus. Names only will be changed. Now shall we quickly ask you some mnemonics? Yes, let the people ready be. Whatever they are in the chat, they can accordingly cover. Okay, hardware, what will you remember? Quickly come back to me in charting. Hardware, what will you remember? Nisha, you have written hardware, software, network, database, which is your components itself. Very good. Everybody has told iPod. Very good. Good one. Good. Good. Sai Shriram, it is not gas. I am asking what is hardware. You are telling what is software. Okay. Anyways, so hardware. Now next, tell me how many activities of operating system activities. Tell me the mnemonics. Operating system, many activities are there. Yes, very good, Sai Shriram. Good iPod. Yes, you have corrected your answer. Tell me how many activities we told for you to remember an operating system. Humpty. Very good. Humpty. Don't you think it is coming like this in seconds? Yes, very good. Humpty. Very good. Humpty. Yes. Tell me the flow of database. Flow of database. How did I ask you to remember? What's the flow of database? Humpty. Many people have answered. Very good. Humpty. Yes. Flow of database. Tell me the mnemonics quickly. People are typing, I guess. The flow of database is very simple. Bits, characters. Many people have come back. Very good. Bits, characters, fields, records, files, database. Very good, Abhinaya. Very good, Suparna. Yes, very good. Yes. Nisha, Vishnupriya, correct. Bits, characters, fields, records, files, database. Very nice. Very nice. So this is the way that you will have to remember. For us, for me, you know what's very important? MCQ cracking is very important in the exam. When you cover SM and IT like this, don't you think easily within half an hour you can get 30 marks? Okay, 30 out of 30 you can get very easily if you go like this in depth. If you go in this depth, you will be able to cover this very, very strong. Yes, Priyanka is right. Sai Shriram is correct. Very good. You don't need to think at all. When you see the question paper from 145 to 2, automatically you will be able to get all the answers right. You will have a tremendous confidence when you wanted to start writing the answers, because it is all based on confidence and positivity. If you know all the answers, you will be able to quickly grasp. If you are getting stuck in one question, everything will get stuck. But if you are confident in the MCQs, I will tell you, you will be able to manage the other questions completely strong. However, you know the question or not, at least you will manage it and come. But we are not writing exams to manage and come. We are writing exams thinking that November 2020 is our last attempt. Correct? This video is mainly for November 2020. It will be suitable for any attempt, but still why I'm saying for you, this is your last attempt, November 20. I don't have any other option. There is no multiple choice questions at all in your options. You should only say, this is my last attempt. So next level, we'll go to the next one. Yes. Now controls. Now what are the controls you have? See the point here. What and all I wanted to cover. Now I wanted to say it very simply. There are majorly two important controls. Now I'm making it bigger. What is this? I have controls. Now listen carefully. The new syllabus people will try to say controls based on audit. Controls based on audit is 2, and the old syllabus people will say controls of BPA. Question is different, answer is going to be same. There are going to be two controls. In BPA controls, you should remember application controls and managerial controls. I'm making it bigger. So application controls and managerial controls. Whenever you wanted to say application controls, there are 6 application controls. Whenever you wanted to cover your managerial controls, there is going to be 8 managerial controls. So what is this? I'll quickly come back and tell you what is these controls are. Now, are you able to see this? Yes. Now see this point, you will be able to understand this. This we can make it stronger. Okay, so what we are doing now, I am hiding this answer. I am only making this controls bigger. So what are the 6 controls? How did you remember that? We remembered very simply. There are 6 and it is called boundary control, communication control, input control, processing control, output control, database control. Indirectly it will be making you remember the hardware, because in hardware we told iPod to remember. In application controls, we will have BC iPod, boundary control, communication, input, processing, output, and database. Now, this is going to be quite big. So, what I am saying, I will mark things which are very important here, so you can accordingly remember. Communication controls is nothing but a telecommunication network. So, you can remember whatever you studied in telecommunication network, you will try to connect that. Okay. So the next important control is boundary controls. They can ask in MCQ. Okay. So what are your digital signature? What is this boundary control, guys? Boundary control. Before even you enter into the system, you will try to have a protection. In the IT, we will say encryption. Correct? We will say intrusion detection system. You will try to say firewall. You will try to say network access control, anti-malware, site blocking. Like that, there will be many things that they will call, which is called boundary control. You have a boundary line in the cricket, correct? So that means before you enter into that, you will have a boundary line, and then only you can enter into the ground. Like that, for the system, boundary controls which will protect you is your boundary control. In input control, you will have one important thing called validation controls. So you can remember validation controls important. That does not mean others are not important, but what I'm talking about is through this they can conceptually ask you many things. Output controls, on the whole, they have asked some 2-3 times, so you can accordingly remember the output controls. Exam oriented question. Okay, exam oriented question. Database control, you can glance it and keep. Now this is your controls, application controls. We will call it as, remember, yes, Abhinaya told cap DP, correct? Now what is this? This is what I have told as mnemonics. If you want, you can also write it and keep, so that you can accordingly remember it when you wanted to cover this. So cap DP, that means cryptography and access control, PIN, digital signature. Like that, you will have plastic cards. Like that, you can remember. If you want, you can note down this mnemonics. Then you can accordingly go and find it from the material, which will be very easy for you to understand. I'll give you 2 minutes time, so you can write it and keep. So you can connect that with your institute material. And I've already told you what is this. Yes. So these are the 6 controls, which is called application control. I'll give you 2 minutes. Can you write this and keep? You can zoom and write it. Two minutes, I'll give you. Quickly write it and keep. One question from this application controls will be for sure. The new syllabus, they will say controls based on audit. The old syllabus will say BPA controls. Communication, whatever is going to be. If you see that fill FI, I is internetworking. We already told how many internetworking processes are there. Switch, 6 are there, correct? Switch, router, hub, bridge, repeater, and gateway. So that is what they will connect. So you should connect with whatever you have already studied. So you can accordingly remember the application controls. What is the next one? Now I'll go to the next one. By this time you should have copied down. So what is this? The next one is called managerial control. So how many managerial controls are there? 8 managerial controls are there. How did you remember? I will ask you to remember it as tips SOD quality. What is this tips SOD quality? I asked you to remember that it is top management control, information tips, TIPS, top management control, information system management control, programming development management control, system development management control. Tips is content. SOD, security administration control, operations management control, data resource management control, and quality assurance management control. What and all I have marked in yellow, they have asked it again and again. So I'll mark it in yellow so that you can accordingly remember what and all they have been asking again and again. That does not mean you will leave the other in choice. All these are very important, but any one question they can ask you, and out of that what I have already colored, you can make your job very easy to remember this. TIPS SOD quality. So this is how you will remember your managerial controls. And for this, both these things, top managerial and information system managerial control, the answer is going to be same answer for both these things. For the first and second, it is same answer. Why I am writing this separately? I don't want it to merge, so I am writing separately and say for the top management control and the information system management control, you will have the same answer. You will cover with planning, organizing, leading, controlling. Like that, there will be 4 stages. You can accordingly remember that from the material. So please mark this very, very, very important. So what we have completed? We have also completed the boundary control. We have also completed the application control, which is called IPC iPod. We have already completed the managerial control, which is called tips SOD quality. So please write this down. I'll give you 2 minutes. You can write this down and then we can go to the next level. Yes, Nisha came back and said planning, organizing, leading, controlling. Yes, correct. These are the 4 important ingredients for your top management control and information system managerial control. If you prepare like this in conceptually and with the connectivity or the techniques, if somebody tells ITSM is tough, smile and come. Because you know it is only in your mind that you have kept it as tough. It is actually not. Now, the positivity is anything is possible. Only if there is a way, if you can find out, it's done. I am already telling you the way. You can easily connect it and proceed further. So that's not a big deal to remember. And don't come back and say, sir, I am not good in theory, I am weak in theory and all. It is all your mindset. There is nothing like that. You are weak or you are good. It is about whether you are interested to know or not. When you have an interest to know, whatever toughness, it is going to be easy for you. Costing an FM, if you come back and say it is going to be tough, you go and meet Hari sir, automatically you will know costing an FM is going to be very easy. Correct? there are stalwarts in many people. If you say accounting is tough, you go to MP Vijay Kumar sir or Shanmunathan sir, you will know that accounting is going to be very easy. Correct? It depends on, there are enormous amount of eminent faculties in CA Institute. I cannot name all of them, but I only just name some 2 or 3. TN Manoharan sir, the stalwart on direct taxation from our side, Padma Shri awardee. So he is again a giant in direct taxation. There are many people, Pattabhiram sir is there. So there are people who made their own subject simple because they wanted to make it easy, because they thought it's easy, it is going to make other people also easy. So it's like that. So we always say this, right? Don't go for transactional leadership, go for transformational leadership. That's what we should do. I hope you should have done now. The next important thing in your third chapter is IS audit. I hope you are able to see this. Maybe I'll make it bigger so you can accordingly remember this. Now, what is this objectives of IS auditing? This is majorly for the syllabus where you wanted to cover IS auditing. What is the difference between IS auditing and audit and assurance? Whenever you do audit and assurance, you audit the books of accounts and form an opinion on the true and value of the financial statements with the help of a software. With the help of ERP, you will try to prepare the opinion on the financial statements. So you will say, yes, it is going to be important. So we will have to audit and form an opinion on the financial statement. So you read standards on auditing, Caro, that, this 700 series, everything you do. With the help of software you do, so it is called audit and assurance. But when you do auditing the software itself, audit of ERP itself, in simple words, we call it as information system audit. How many objectives are there? 4 objectives are there. What are the 4 objectives? You should have data integrity. That means it should be protected and with an user ID and password. Second is asset safeguarding is very important. Third is efficiency and effectiveness. System efficiency objectives, system effectiveness objectives. I easily make people to remember it as DAS. DAS. DASS. Data integrity. D. Asset safeguarding, system efficiency, system effectiveness. So you can make your job very, very easily. So you can remember that. Why do you need audit of information system? That's the big question, correct? Why will you need audit of information system? There are some needs. If you are able to see this, you will understand. Number 1, organizational cost of data loss. Maybe I'll make it bigger so you can accordingly remember it. What is this? Organizational cost of data loss. That means you should not lose any particular data. So if you have information system, because when the IS auditor wants to come back, he should not go and have a problem when he does auditing. So he will try to do the audit of information system so that no data loss will be already there. Second, when there is incorrect decision making, that cost you cannot manage if you don't do audit. So audit of information system. Computer abuse, you can change over the system requirements. So before that, you will try to do audit and ensure it is properly done. Fourth, computer error, high cost of, when there is a high error, there will be a high cost that will be incurred. So we should have this. Controlled evaluation of computer use. You should know that this keep on be changing. So before it changes, you will have to do that. All these are basic points. Maintenance of privacy, undoubtedly, yes, you will maintain. And value of the PC, hardware and software and other personal related, people related items you should concentrate. So they will talk about value of the PC, hardware, software and all is going to be important. So how did we remember? Forecast, control it, maintain it and then create a value. So what are that 4 costs you will remember? One is cost of data loss, cost of incorrect decision making, cost of computer abuse, cost of computer error, and then you will say you will have to do control, maintenance and then find out the value. Easily you can remember forecast CMV. So you can remember that. So you will never have a problem in saying, why do you need to audit the information system? Need to audit the information system for this particular purpose only. You may know it conceptually, but when they ask in the exam question, without remembering this, how will you do that? So we are connecting both these things. Are we clear? What is the next one you should cover? The next one is audit and assurance, which they have already covered in your auditing. Standards on auditing itself, they would have told. Documentation means 230 you will cover, correct? So I'll make it bigger. So if you want, you can accordingly remember this. You would have already covered this in SA 230, correct? So you would have told what is going to be there for audit documentation and what is working paper file, current file and all, permanent file, all this they will say. Audit evidence means it is 500, 501 external confirmation, 505, all these things you will cover. Inherent limitations of auditing you will cover in standards on auditing, correct? So all these things is already there in auditing, so I am not going to touch, and it is not going to be asked in EIS also. The next thing is audit tools, very important for exam. Actually, when we were taking for CA final, they will ask this question again and again, and one of those questions will be for sure in the examination. So we should remember this. Now they have brought that, the institute have brought that from ISCA, Information Systems Control Audit, to your EIS paper. So we should be very careful in knowing about what is going to be there in audit tools. So we will remember audit tools only. No, so where they have taken it from ISCA, so I have brought indirectly ISCA itself, correct? That ISCA and this ISCA is not actually the same. That is Information Systems Control Audit. Here I am trying to say, remember ISCA, so you can cover this. What is this? Integrated test facility, then snapshot, scarf, continuous and intermittent simulation. I will tell you what is this. The scarf is system control audit review file. So I will write this so you can accordingly remember. What is scarf? System control audit review file, correct? So this is how you will try to remember your scarf. The system control audit review file. They call this as embedding of all the audit software modules. One of this question will be sure. What is the CIS? Continuous and intermittent simulation. Continuous and intermittent simulation. What is this they will do? Whatever the exceptions it will be there, that and all the CIS will try to do. What are the exceptional activities? When you do audit, the system itself will try to deduct what are all the exceptions that you have. So it will try to deduct. So what I will try to remember, I will try to say it is exceptions. It will trap the exceptions. I will tell you the MCQ. So accordingly, at least you can remember that trap exception. What is audit hooks? It will try to find out what is the suspicious activities. It is not exception. It is doubtful. It may or may not consider. So it may consider the suspicious activities. What is this snapshot? We take screenshot in the mobile. Like that, if there is a mobile of images, you can accordingly remember. So remember screenshot. Don't write screenshots in the exam. This all the faculties will try to make you remember for that, so that you will say it will take images of the flow of transaction inside the system. So you can remember screenshot. So you can keep that as evidence. It will take images of the flow of transaction inside. Here, like backup, remember the backup, because it will try to create a dummy entity, and inside that it will store the whole backup data so that they can do comparison. Who will do this? IS auditor will do. So what I'll write here, I will say this is be done by IS auditor. IS auditor means what he should have studied. He should have minimum studied SICASA. In our institute, we will call it as BSA or ESA. Correct? Information systems audit. So they will try to connect this. So basically the qualification should be that. So we should be very, very careful about it. So you should know these keywords. They can definitely ask you and make the question paper strong. So we should be careful in knowing that integrated test facility is, how will you remember? Integrated test facility, snapshot, scarf, and continuous intermittent simulation and audit hooks. This is how you will try to connect it and finish. So this is how we wanted to. Now, apart from this, what you will have in the third chapter, you will have controls based on resources. What is this control based on resources? You will have something called physical access control, logical access control, environmental control. Indirectly, I will usually say PAC, LAC, and EC. What is this PAC? Physical access control. What is this LAC? Logical access control. What is this EC? Environmental control. So I'll make it really strong. See what I'm going to do here. So in this audit tool, in this here, so I will write here what I wanted to. So controls, I'll put it in here. So I'll make it strong. I will make it bigger also. So controls will actually be many types. So the controls, I am marking it here. I usually say controls is 4, 3, 2. What is this 4, 3, 2? Objectives of controls are 4 in number. Preventive control, deductive control, corrective control, compensatory control. There are 4 objectives of controls. We already told it can be prevented or detected and corrected. Then you can compensate. That 4 controls you can try to remember. What is that 3? 3 are the resources. I already told you now. It is physical access control, logical access control, and environmental control. In that, logical access control is very important for the exams. So please mark it. I am also marking it in the red color. Now, physical access control also you will have important. What is the difference? Physical access control means I wanted to have control, but physically. There should be people involved in connecting that and seeing how it is actually making that job. So like that, if you try to do, then they call it as what control? Physical access control. But through the system, through automation, when you wanted to connect, it is called logical access control. Simple example I will tell you, you will understand. ATM. If you see the ATM, automated teller machine, you go and withdraw cash there, right? You can check deposit, you can do everything there. Now, generally, what is the ATM built for? It was built for logical access control. What does that mean? They are trying to say, for that logical access control, you need to, it should be, the door should actually be closed. You should swipe the card. That means you should insert the card. We call it as contact card. You insert, the red will turn into green or fluorescent, then only door should open. Then you go inside, door should get closed. You finish all your withdrawals, you count everything, you take the card, you check whether the transaction processing system is correct. That means you will have to get the message and it should be in order saying that after you withdraw the cash, you will have to say successfully debited. So transaction processing system we will say in information technology. Now that is going to be done. If you are done, then there will be a switch inside. You press that switch, then only door should open. Then you come out. Another fellow who wants to will insert the card and then go. Now this only is the purpose of ATM, but it is not like that now. It is always open and there is security there. Correct? So now instead of security, they wanted to keep everything logically. It was previously logical access control. Now the security is there because there are problems that gets created when you wanted to lock the door when somebody else coming for the theft, so you will not be able to. So logical access control become physical access control. So security is there. So the type of controls that they will talk. Environmental control, how to protect with the environment, how you will have to keep your building strong, how to manage your business, all these things they will try to say. Okay, so the next one is audit. That's what I am writing now. Audit, we already told what are they. I told 2 things, 2 only, correct? What are the 2 things? Application control and managerial control. You remember this? Application control is 6 in number. Application 6 control is 6 in number and managerial control is 8 in number. Okay, so we told that very clearly, and 6 and 8. So this is how you will try to remember. When you wanted to cover the 6, we told what? PC, iPod. And when you say managerial control, we say top management control, information system management control, programming development management control, system development management control, security administration control, operations management control, data administration control, and quality assurance management control. This is what is there in your controls. So we should concentrate on what is important, what is not important. Now with this, what are we completing? This is what is there in your third chapter, which is called Information System Components. Now, I told you it's a challenge for us to know what and all is there. Are we taking it convincingly and completing it? Fully, you cannot do in 2 hours. You know that because it is almost 100 pages. What we have done, 100 pages, I have brought it in a simple way to manage that and say, if you practice like this, you can cover it up. Correct? I have done a teaser or a trailer work. The main picture is already to be done. So I wanted to give a quick revision so that people can do it very, very easily. Are we clear? Shall we sum up quickly and then we can wind up for the day? Yes, number one. What is that we have told? Information system components. Before information system components, we told what is data, information, knowledge, database, what is system. We told the concepts first really strong. Then we told what is hardware, what is software, what is there in database, what is there in network, user is nothing. Hardware we told iPod, software we told gas, general software, application software, and system software. And you can remember that very easily and say, this is how you have covered database, bits, character, field, record, file, database. And we also told this is how we will cover the flow of database, and we told models of databases on HORN, hierarchical object oriented relational network. We completed that also. Then we finished the software, application software. 7 types are there, six or seven activities, and we remembered Humpty. We completed that also. Then we opened up something called controls, 4 comma 3 comma 2. Just now I made it really strong. After that we went to IS audit. We told what is the need for audit. We told what are the objectives of IS auditing. We told what are the IS audit tools, and we made that really, 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 really strong. This is how we completed this whole session. What we have completed in these 2 hours, I wanted to sum up and say, this is how we have completed in your chapter. Now, guys, the point is very simple. The point is you should try to have keywords notebook. Whatever I have told, you should have written in keywords. The second is mnemonics. Mnemonics is a magic for your mind, so you can remember it very easily. So if at all you think, will I be able to pass EASSM or ITSM? I hope yesterday and today and tomorrow should actually be an eye opener for you and say it is not going to be tough. It is very, very easy. So stop speaking negatively. Positively, if you ensure that this and all can be done, you can manage it very, very easily. So we will come back again tomorrow and see what is there for risk and controls of your EIS, and we can manage our job very, very easily. Yes, so I hope you would have understood this. Guys, give me in the comment where have you understood all this, so that I'll be happy when we wanted to cover it tomorrow. Are you getting the concept strong? Give me the comment. Yes, very good. Understood clearly. Very good. Good. Rakshana, Nisha, Sai, very good. So I hope, yes, Malavika, Shanmati, very good. Asha, yes, very good. So good that people are able to get it. I hope people who are watching this video also after that will be able to. You can come back and say how you have taken the session and enjoyed, because positivity is contagious than anything. Correct. So sometimes negativity we speak unnecessarily too much on something. So positivity we are not doing. So it will inspire people. Why I always ask for comments or the feedbacks from people is, it is not just to know about what we have done in the class. It is about if you tell that you are taking it easy. Yes, sir. Now I am studying it easily. Now I'm able to do better. So the words that you speak again and again, when your words are listened by your own ears, it goes and sits in your permanent memory. This is what they will say in psychology. So when you say again and again, yes, sir, yes is easy. SM is very easy. If you know the concepts, it's easy. If you know the memory, it is even more easy. Like that, when you tell again and again, we will bring up that positivity. And that's the purpose I'm here for. Not just to tell the concepts, but also to inject positivity. We usually say this, right? Positivity should be coming from within. Correct. I am not saying no, I'm not denying it. But there should be someone who wanted to tell you that the subject is easy, and then you can continue further. And that's what I'm doing, a bridging gap between what the ICA wants to expect and what is that about technology. So let's make it really, really strong. So I hope you would have enjoyed this session. Now I am leaving this to SICASA people, handing over to the SICASA.
Thank you so much, sir. It's really a good session and we learned a lot, sir. Friends, there is another session on EISM by tomorrow evening 5 p.m. on the topic Risk and Controls of BPA and Core Banking Systems. Kindly watch, learn, and share, friends. Thank you once again, sir, for your valuable time with us. Thank you, sir.
Thank you. Thank you. Have a nice day, guys. Thank you.
Thank you, sir.